Silly me, testing sound. Indeed, it works. All right, then. Live on all platforms. So today there are a few different things. One, I decided I want to just bite the bullet, be able to randomly print out tokens so that when there was an error in the list of tokens, for example, when the test expected a particular list of tokens and it didn't match, that the CTRE library could in fact print out the tokens that didn't match. Um, yeah, that's uh, that's mainly what I'm going to be working on today. I don't know how long it's going to take me. I haven't actually, I want to use the format library and I haven't ever written a new formatter. I don't want to use cout O streams to do it. I don't like the O stream library very much. And so that's why I don't want to use it. But yep. All right then. I already have begun a little bit of work on the tokens to kind of regularize them a little bit and to fix some issues I have. So I'm going to get right into that now. Doing a little bit of maintenance of my stream and also avoiding having all kinds of bandwidth issues. All right then. As you can see, I have been working on this. I've been doing a few things. One, I wanted to make using the GCC latest tool chain work properly inside of CLion, and I figured out how to do it. Well, I can show you that. So if we look, we have managed tool chains here and GCC latest. You can basically just set you can use this environment variable thingy to set an environment variable. Uh, Actually, look at this file. All it does is set LD library path, which is the biggest blocker here for using GCC latest, because it comes, of course, with its own set of libraries. And when you compile something with that version of GCC, you would like to use those libraries in preference to other libraries. So yes, but otherwise you don't. For everything else in the system, you want to avoid these libraries like the plague. There probably won't be any, major binary compatibility issues, but there might be. There should be version differences if there are some major uh, compatibility issues. I don't know how well the shared library system is going to handle those version issues. So that's what I have to do with this. Is I have to, whenever I launch anything that's using this tool chain, I have to set it up so that uh, it uses the right thing. And right now, the debug slow, which is the profile we're using, the CMake profile we're using, the debug slow profile, does indeed use the DCC latest toolchain, and it works. Um, Sadly, this thing with build type, like something's up with this because I should be able to add, like you can add your own build types to CMake, but I don't know how to get them added to this list. Ah. And I want debug slow and debug to be distinct because I compile with dash capital OG with debug because that's usually good enough. But debug slow compiles with dash O0 and turns on all the sanitizers. So I think that that's worthwhile to have as a different profile. And I wish that Sea Lion had a better support for that. Anyway, so what changes have I made to the parser or to the tokenizer since everybody looked? So there's actually a major bug that I discovered offline with the parsing function or the execution function for functions. I'm mildly embarrassed to have overlooked it. And it's a huge issue. It will cause problems if you have function calls that are used to generate the values for parameters to another function call. That actually won't work properly with the current code, and it will fail in a kind of spectacular and weird fashion that may in fact involve memory issues. But here we go. So here, yeah, in order to make this all work reasonably, I had to use this string view literals thing here. But, and I think that'll be okay. I think you have to try and explicitly import this from the tokens namespace in order to get it. And I'm not going to be doing that. Um, so it should be okay to have it in this namespace. The reason why I want it in this namespace is so that these work. And so for each of the different kinds of tokens, I now have a string for what, the name for that class of tokens. Then another thing that I changed is I added the semicolon. I changed it so that it's no longer a valueless token. Before I had the semicolon being its own special kind of token. It actually possibly should be turned into a punctuator because the semicolon kind of fits into the same token classes as punctuators because it's not an operator. Um, and I don't consider dot to be an operator, for example. Like the fact that dash greater than in C++ or C is an operator leads people to believe that dot is an operator in C. I don't think it is. I think it's a punctuator thing to use to qualify exactly what thing you're talking about when you have a set of nested things. Um, just like colon colon is a punctuator. So I think maybe semicolon should also be a punctuator. The reason I created the punctuator class is because I have comma being a punctuator. This language doesn't need C++'s comma operator because braced expressions have values. You can actually go something equals. I don't know if you can do something equals braced expression. I might add that syntax at some point in time, but internally in the evaluation system, braced expression, in fact, do have values. The all right then. Now down here. So this is part of what I did. Like, okay, this I think can't just be explained away with a diff. So I added this to semicolon. And you notice how every single other one value is in fact a variable. But for semicolon, it's a static const member because it's the same for all semicolons. And so it doesn't need to be a variable. There doesn't need to be any kind of data in the class in each instance of the class to tell you what this value is. It's always going to be semicolon. Um, so let's go look at this here. Let's go look at this other thing that I changed because this is it right here. I changed operator equals because I needed the operator equal to make the tests work, because the tests, when you have a whole list of something and you want to see if it's equal to a whole list of other things, everything in that list has to be comparable to every other thing in that list. So I have to be able to compare any token, which is a variant here, with any other any token. Um, and I did this a while ago. And index is like the internal uh, value and variant, the way to ask variant, what type number is it? Like, what type is it? Without saying, is it an unsigned integer? Is it an identifier? Is it a punctuator? Without asking it if it's a specific type, you just ask it what the numeric value that it is assigned to the type that is inside the any token. And that variable, that numeric value will be unique to all of these. It will probably be 0 for unsigned integer and 1 for identifier and so on and so forth. But there's no guarantee that that's the numbering scheme that was chosen by the implementer. All that's really guaranteed is that each unique value you get from from the index function for a value of this variant will correspond to a different type, and that there's a one-to-one relationship between the number that you get out of index and the type. It might be that the standard says that there's some kind of ordering. I prefer to not assume that there is, because there's no particularly good reason why there has to be an ordering. And I'm not quite sure what will end up happening if you have, well, actually, I do kind of know what happens if you have nested variants. Um, and so it's entirely possible that the standard has decided that there is defined ordering here. There's a pretty reasonable way to do it, but I don't like making assumptions like that if I don't have to. Um, so even if the standard allows it, I prefer to, if I don't have to, not make the assumption. And all I really care is whether it's the same type. And so I just check, is it the same type? And if it is, return false. And then one type that it can be is valueless by exception. Basically, you somehow constructed one of these and there was an exception during its construction, so it wasn't fully constructed, so it doesn't have a value. Valueless by exception. And if that's the case, then that means that the index of both of them was the same, and that means that returns true, because two valueless by exceptions are the same. We'll just say they're the same. I could say that they're always different from each other and they're different from everything else, but uh, I don't know. I decided that they're the same. I think that that's actually a fairly reasonable choice. Either I think would be a pretty reasonable choice. Um, if they're different from each other, that would mean that trying to compare to would never compare equal. Uh, but on the other hand, a valueless by exception variant token here should never actually make it into any data structure ever. There shouldn't be any valueless by exception ones. So it's kind of a test error if they show up. Um, and they certainly never show up in the expected result. So it's kind of almost pointless, really. Um, the valueless by exception should in fact always fail this one. But as, yeah, I had to do something. I wanted to cover that case. And so that's how I covered it. Now the rest of it is covered in a really weird way. I call a visitor with a template lambda. Um, visit is a thing with a variant, and basically it calls an appropriate function based on the real type that's in the variant. It uses if you only have one argument to your visitor, um, your visit function only has one argument, then visit will expand into a big switch statement or a jump table, which will probably expand into a jump table. Or maybe it expands into a jump table directly. It usually chooses an extremely efficient implementation when that's what's going on. But when visit, where you give it two values, then it does some kind of elaborate thing with virtual functions and all kinds of stuff. It's a whole thing uh, to set it up so that it works with two different values, a function that takes two values. So what I'm doing here is I already know the type of B, the real type of B, if because a.index is equal to b.index. I can be guaranteed that by the time I get here. So all I really care about is the real type of A, because the real type of A, the variant type, the variant that A is going to be the same type as the variant that B is because their indexes are the same. And so that's what this that's I can just capture B as a reference to B and then just go, hey, the B value is the get of the type out of B. We know it's going to be the same type. I can just do this get and it will never throw an exception because it just can't. I could actually mark this no except. I don't know. That would be an interesting thing to do because it shouldn't ever throw an exception. Um, then it compares A dot value with B dot value. Now, what it used to do, as you can see over here in this code, it used to check, is it a semicolon? And if it is, then we just go, all semicolons are the same. And otherwise, it would do dot value. Well, I added, you know, this to semicolon. So all semicolons have the same value. Um, it's what I should have done in the first place instead of having that if const expr there. And now this code is clean, but of course, the comparison is very different and always guaranteed to be true if uh, the type is semicolon. And the compiler will realize that. It will go, oh, you're comparing this one's static class level variable with that one's class level. They're the same. They're the same. And it won't even bother with the comparison. It'll just assume that they're the same. It will have the same effect. But it makes this all cleaner. It's always comparing the value. So one of the reasons I wanted to do that is because my formatter is probably going to care about the value. And it's going to print out the value. So yeah. Now, the thing I looked at with the formatter is I'm going to need to know how to get a string representation of the value for any given value. Um, and I'm not sure exactly what to do about that. So I'm going to take a stab at doing it. Do I even include format in here? I do not. Uh, no, I could just forward declare the class. I can say that this thing exists. So that's what we will do here. We'll say that there is a template and that it's not quotable string. It's going to be, right, that there is this class. And so then I don't currently have a tokens.cpp file, but now this would require me to add one. I don't care about this core. And this is what we're going to do here. And then I'm going to have to also include in order for that to work. I think. Is that the right include file? Yes, it is the right include file. Does this work? Does this compile? Since I'm not using the formatter for anything, let's see what happens if I try and build this. This is what we're going to have to do, and it's ugly. Now it should work. All right. It does compile this. All I'm doing is saying there's a specialization. It exists. Um, I'm just not defining the specialization anywhere. I want to define it in a CPP file. Um, all right, CPP file, here we come. We have to create a new one. New C++ source file needs to be added to all tests. And probably also lecture test. There, I'll call it token debug.cpp. Can change its name later if I don't like it. And let's look at what we've been doing for copyright in, let's say, here. And forward declarations. There we go. There. Argument dependent lookup will find this because any token is in the tokens namespace. So argument dependent lookup will find this operator. And I wanted to add this as a say this exists without saying as little about it as possible. And that's not what we're going to do here. What we are going to do here There. All right. Now let's look at how this is implemented over here. Um, we are going to have to do some now. What we will do here is quotable string and not quotable string. Const. Be consistent about using east const. And barely sliding in under our limit here. Do it like that. There. All right. How does this work? So I am not completely sure how this part is going to work, but um, like how do I create a new parse context? Because that's kind of what I want to do. I'm not going to get fancy, and I'm just going to have one kind of formatting. And I'm not going to allow any kind of format controls. No column widths, no nothing. We'll just worry about all that stuff later. Well, after I take the time to understand how it works. And so we'll just drop this out style for now. Um, and then what we will do here is we will say token visitor, and then we will have and then all of our various token types, which are going to be listed here. I'm not using. So an explicit uh, constructor here. All right, so now the format context is going to be, so how do I use the format context again? So format two, format. Let's check something here. So is that the right? Oh, so there are some clever tricks I could play. I'm tempted to play here because one thing I can do here, well, actually, in order to play my trick, I'm going to have it be explicitly a template. Right? And then I can do token type and then const, actually. And then I can say, and then say UE dot R. And then T dot value, right? That's what I could do. And that works for semicolon, and it works for uh, unsigned integer and identifier. Um, but it doesn't work for anything else. It works for these three and not for any of the others. Um, so is same. Is there an is same? I know there is same comparison. I don't know what the is same comparison is. So let's go ask. I'll ask our good old friend AI chat over here. New chat. And this time we will say no. We will go for GPT 5.1. Go for GPT 5.2. Okay, so I have to include concepts. And then I can do this. Uh, well, that's fanciful of it to think that I have a string literal. I do not. All right then. And I believe this would be void. Oh, wow. That's certainly an interesting idea. So this is in type traits, which I shall need to include here. Right? This is it's a particular kind of expansion. It's a particular kind of template expansion where it will basically expand all of the possible values of US with logical OR between them is what it will do. Um, it's a left something expansion. I wish I could remember what it was called. Fold expression. That's right. It's a right fold expression. Um, I've used them before. They are very useful when they're useful. Now what I can do here is I can say, and I can just skip the requires clause, right? And then I can say here, there we go. I don't have to have a requires clause anymore. And for that one, what I can do here instead is I can do T dot like that. Now, of course, none of the T currently has a Valster array, but that's easy to fix. And I, in fact, have that Valster array squirreled away someplace else. And the fact that I have that Valster array squirreled someplace else means I'll be able to move it. Hey, it should belong to a project target. I told it to add it to both project targets. Wow. All right then. So we'll just have to add it here, and it also belongs in here. There. All right. What are we doing here? We're basically trying to make tokens, something that can be printed. Uh, just responding to some people trying to talk to me in another window. Actually, should set myself up as I need to go off and do something for just a second. I will be back. Uh, I will be still able to talk, unable to see chat, but I do have to get up for a bit. have to get up and do one last thing because it's starting to actually get a little cool in here. It was too warm before. There we go. Doesn't look like I missed anybody while I was away, sadly. I mean, I would have been sad to have missed them, but I'm even sadder that there was nobody to miss. uh, all right. Oh, yes. This needs a type name. And then here, I believe in Lexer test, I have all of these things here, right? And I call these valsters. And that's way, oh, that's 79 columns, so that's fine. And here, for example, so as you can see, basically valster here is going to be just a list of what all the enum values mean. Um, and am I already including array? No. Yep. All right. We go through and do this, copy these from Lexer, um, and then I can actually change the way Lexer this thing prints things out uh, again. So and it should be And I have parens and curly brackets being their own. It actually kind of makes sense for parens and curly brackets to be their own. But not open paren. And open brace, close brace. Yep, that's exactly it. AI is good for something sometimes. Open, close, and then here. Little work up front, less repeat code. All right. So everybody either has a printable value or valster, which converts to yep, converts an enum type to a printable value. This stupid trick. Now I don't need to use this stupid trick. Da, 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 da. Now we have this print visitor. So is that how context.out should work? So how does format 2 work? All right, it's not in here. It's in some earlier thing. Oh, stupid inability to handle focus following mouse. What happens when I try and build it? Oh, but I thought there was a special version of Format 2 that was for O streams, right? No, there is not. Okay. Is there a version of Format that allows you to give it? Nope. Okay. Well, the requirement is that it be an output iterator, so we can just use uh, again, stupid set JetBrains and its inability to do this. Um, I need the member named parse. That's right. And we look at formatable, and then we look at formatter, and then we look at this sample formatter here, and we look at its parse function. And here's what we do. And I will look at how to do something better sometime in the future. Right now, this is good enough. There. Now let's try and build it. I don't understand this error. I just realized that since this actually contains template members, I can't use it. And even worse, uh, kind of annoying. This I can do though. Where is OStream iterator from? Uh, let's look up here OStream iterator and find out what header file I should be including for it. It's in iterator, so I should include iterator here. Oh, stupid thing. Now what happens? Okay. Well, this is how this is supposed to work, right? I'm supposed to be doing this. Does it really not work with :std? Is there some kind of weird thing in the standard that causes this to make it invalid? Apparently there is. What a bizarre thing. All right. Now we have what the heck is this? Well, yeah. Oh, I declared it in the wrong namespace. All the tests succeed. Let's try making one of the tests now fail. The tokenizer, let's try having it be operator. Oh, let's make it operator boolean and see what happens when I run it. Come on. Is it really taking the compiler that long? Test failed. Keyword var, identifier x, operator equal unsigned integer semicolon equals keyword var identifier operator log and. Var x equal unsigned 3 semicolon. Yep. It doesn't highlight which one is different, sadly. It should, but it doesn't. But at least in the expansion, you can see you can examine it yourself and figure out which one is different. Keyword var, identifier x, operator equal, operator log and. What's that? Unsigned. I don't know why I called this bool and log and, but anyway, we'll fix that sometime. It's a refactor. Unsigned integer 3 semicolon semicolon. Yep, it all checks out. So that's all working. That's a long time. And that build time was long too. Welcome, Sir Elfman. The today's project has been adding support for STD format to tokens so that I could just use format to print out tokens and also just use the OStream operator to print out tokens. This is so that when the tests run and they fail, they can just give me the list and show me what the list has in it. But and it works. I got it to work. So, but yes, it's all the formatting stuff that's causing it to fail. So let's try running it again. And we wait for it to build. See, we need module support. That's what we need. That would solve this build time problem. Oh, you use your test suite uses JavaScript? How does that work? Ah, okay. Oh, that does make sense. Uh, one, I'm not overly familiar with JavaScript. And two, I wanted some tests that were a little more fine grained, like this tokenizer, for example, all these tokenizer tests. Most of the programs happen to be valid, but it doesn't matter whether the programs are actually valid or not because they're not being run through the parser. I'm just testing the tokenizer to see that the tokenizer, in fact, does the right thing. And that enables me to make programs that are invalid in very selective ways just to see what the tokenizer does with them. Like, I'm going to take a keyword and put a funny character after it. Does the regular expression thingy eat the funny character too and then discover that it's not a keyword? Or does it see the keyword and go, oh, I found a keyword and stop right there? Ignore it and treat the funny character as another identifier. Like, is that something that happens? So, yeah, having expected errors is a way to get some of what I'm getting out of this. Um, out of these unit tests that are less black boxy about things. By having expected errors helps. I, of course, completely punted on error handling in this, so that's that then. Um, Another thing I get to do now that this works, um, huh, Clayne thinks that this is doesn't work, but I don't know why. Um, anyway, this is the formatter. Uh, I played some clever tricks with the formatter. I'm actually particularly proud of this. The print visitor, and then the print visitor, I as part of the print visitor, I have it in the priv namespace for the tokens, and I then create these concepts. One of is a templated concept that actually probably should be a library concept, which is basically saying this type is one of, this yes, the type given is one of any of the other types that are given as arguments, um, which is a pretty useful concept. Um, and then has printable value. I check is what, is the token type one of these? And as has enum value, I check is the not. So all of the ones that don't have printable values have enum values. So, and then I use this concept so that I basically have two different versions of the function that both take a template parameter, but the template parameter is restricted by the concept. So one of these versions won't work for some arguments and the other version doesn't work for other arguments. Um, and so, uh, yeah, this enabled me to make my print visitor very simple because the thing to do if the value is printable is you always do this one thing if the value is printable, no matter what the token type is. Um, And even though t.value refers to a different field for every single token, it's still the same name, so the template expands just fine. And then, and same with s token name. And then for ones that are enums, you actually use a lookup table to look up the value of the enum. And it's the same for all the enum classes. I went and added this table, this lookup table that has the same name in every class that uses an enum for its value. And there we go. I was able to compress down the overall verbiage of the implementation quite a bit by doing that and have much less repetitive code. Um, you know, I could say, uh, instead here, in fact, I probably should. There. Let's try that. Have you ever used concepts? Like the language feature concepts? Because clearly you've used concepts. Oh, they're pretty, they can be pretty powerful. Um, you can see how I used them here so that I could have just two versions of this output function instead of a whole mess of different versions of the output function. And here in Lexer test now, one of the nice things that they did with concepts is they got burned. I mean, it turned out to be fantastic in one way and terrible in another way, but they kind of got burned by the fact that it turned out that templates were Turing complete. And so they worked very hard when they were defining concepts to make sure that concepts were not Turing complete. Um, and they succeeded. Templates are not, or concepts are not Turing complete. Um, so that's good. uh, um, anyway, I am now curious as to what the AI is going to make of my changes. I always like getting the AI with well, that's actually not too bad of a, that's not, this is one of the very first times that it's given a commit message. That's a good commit message. Uh, so let's see. Oh, sure. Paste in the URL. And here, All right, now I can refactor all of this. And get rid of all of this redundant code. There we go. Hmm. I will, though it might have to wait until I'm done with this stream. Um, which means that you'll have to come back in the next stream and I'll tell you. Uh, what is the problem here? Oh, there we go. Well, got an extra close parent in several spots. Build times that are too long. Grr. Yeah, the message is too long. Still a bit too long. There. I'm so glad I implemented those commit hooks in Mercurial so that I don't have to worry about this kind of thing anymore. All right. You know, there's other things to be done. There's actually a major bug that needs to be fixed, but the bug is a bug that tell you the nature of the bug just because, but it's a bug that needs to it's going to need longer than a half hour worth of work to fix. It's not that hard to fix, but it is a bit of a pain. So let's go here and also back in parser.cpp over here. Uh, here in func call, no, here in statement list, and then over here in I didn't want you to do that in this window. Where is statement list again? Yeah, but this is not the right one. Also not the right one. There we go. There we go. So here, and then over here inside of simple evaluator func call. Here's the bug. There we go. So function call, lots of asserts in here. Find the identifier for the function that we're calling. Double, like assert that the identifier actually happens. Well, one, assert that the uh, that the identifier refers to a valid place in the stack. Then assert that yes, okay, yep. So assert that we got a valid identifier. We looked up the function call by name. Then grab the value of that identifier and assert that the value actually holds a function declaration. Okay, so now we can assume that it holds a function declaration. And the reason why we're asserting this is because the parser should prevent us from making a function call using any identifier whose type is not function declaration. Now, auto const star const func decl blah blah blah. I don't know if I actually in the parser, because I can do this in the parser, check that the list of function arguments is the same size as the, I don't know if I do that, make that check. That's the thing I should add to the parser if I don't make that check, that you're passing in the number of arguments that the function expects. But that's a different thing. It's not exactly a bug. It's a thing that the parser is not catching that it could catch. So now that we know that we have a function declaration, make sure that the function being declared is not null, that in fact there is a function there that it's pointing to, and that the function arguments are empty. Oh yes, that the function arguments, which is a shared value. It's a value that's part of the simple evaluator. It's a member variable of the simple evaluator. Assert that it's empty, which surprise, surprise, there are cases in which it will not be empty. Now we reserve arguments for all of the parameters of our function. So we know how many parameters there are. So we set the reserve size for funcargs, which is a vector, to the list of all the parameters. And we go through all of the parameter expressions, because each parameter is going to be, there's going to be an expression that will result, give the parameter its value. And we, evaluate that expression. And then we in place back the current result, which of course is the result of evaluating the expression. The problem is the expression might itself be a function call, which will then need to set up funcargs, but funcargs won't be empty anymore, and this assert will fail. That's the problem. Now I didn't ever get to a point where that assert did fail. I just thought about it and caught the error. Well, AI looked at my code and caught the error before I actually ran it. I'll be honest. It was AI. And then uh, once I've put all the function arguments in this function argument thingy, um, then I run the function body. The function body is always going to be a statement list. So then we go up here to statement list. We have a special case here that checks, do we have some function arguments? If we have the function arguments, copy them into the stack frame for the new statement, for the statement list. And then clear them so that we basically consume the function arguments. If we consume the function arguments, then funcargs is empty, which this assert says funcargs must be empty now. So that's what I was thinking, function arguments, you pass in all the function arguments, and then you consume the function arguments and then you clear it. But I forgot that in the course of evaluating the function arguments, you might be making more function calls. So I need to turn this into a stack, or I need to change the way the handoff works so that it's that this is actually a local variable, and then I swap the local variable into funcargs. That's an option too. So that's probably what I'll do, is make it a local variable and then swap the variable into funcargs down here before I call visit the body. That's probably what I'll do. But that's the problem. So as I said, I just spent several minutes explaining the problem. It's going to take me longer than half an hour to fix the problem, especially since once I fix it, I won't be able to rest until I, in fact, have written some tests that do some actual function calls. And yeah. Oh, the other thing is the uh, parsing code to parse out function definitions and function calls hasn't been actually hooked up yet. uh, so I just wanted to finish the debug stuff for the token output just because it's very nice to be able to just print out tokens and have it work. So yeah. Anyway, so I think that I am done for the evening now. And I will go take a look at your codec code your yes, I will take a look at your thingy, your web demo of your language, and I'll have something to say about it next time I see you. It was nice seeing you on stream, Sir Elfman, and I hope that you have a good rest of your evening. I'll probably be back on. I think I'll be back on Thursday. I hope to be back on Thursday.